Welcome back to our chemistry class. Today we can discuss equilibrium constant for heterogeneous equilibrium. So page number 8, second volume, page number 8. Equilibrium constant for heterogeneous equilibrium. So we know that one. What is about the heterogeneous equilibrium? What is about the homogeneous equilibrium? That's a reactant and the product. The reactant and the product are in same phase. Am I right? We discussed the previous class. What is about the heterogeneous equilibrium means? The reactant and the product are in different phase. Let us consider one of the following heterogeneous equilibrium. I am taking calcium carbonate. Calcium carbonate. What is the formula for calcium carbonate? CaCO3. Calcium carbonate. It is in solid state. This undergoes equilibrium reaction. That is both forward and backward reaction. One of the calcium combines with oxygen, we get calcium oxide. That is also solid state. And here carbonate, out of this carbonate, carbon dioxide gas is evolved. That is CO2 gas is evolved. Am I right? So here in this equation, reactant is a solid state, but the product is a solid and gaseous state. How can we write the equilibrium constant for the above reaction? Equilibrium constant Kc. What is that one? Kc. Equilibrium constant Kc can be written as, don't forget that, always the product divided by reactant. Product. Which one is the product? Calcium oxide, that is in solid state, am I right? And carbon dioxide, gaseous state. Calcium oxide, the active mass of CaO, active mass of calcium oxide, and CO2 divided by calcium carbonate, CaCO3, calcium carbonate. Whenever we are writing the equilibrium constant Kc, don't forget that we have to start from product divided by reactant. Okay, don't forget that product. Which one is the product here? Calcium oxide, carbon dioxide, next divided by reactant, that is a calcium carbonate. Okay, here the concentration of pure solid, is always constant. Here, that is a pure solid means we can be taken as here. Calcium oxide is also pure solid. Calcium carbonate is also a pure solid. Am I right? Calcium come to the reaction. Here, calcium carbonate is occurring in solid state. Calcium oxide is also solid state. Am I right? So, a pure solid always has the same concentration at the given temperature. Okay, a pure solid always has the same concentration at a given temperature, and it does not expand to fill its container. The concentration of a pure solid is a constant. Don't forget, the concentration of pure solid is a constant. So we can write the equation. How can you write the equation? Kc, equilibrium constant Kc is equal to active mass of carbon dioxide. Am I right? Because the calcium oxide and the calcium carbonate are in solid state. So the concentration of a pure solid is a constant. Don't forget that. Now, how will you write the Kp? Kp also same like that. Already we take return practice how we write the partial pressure of the reaction. So we know that one. But here we are now here writing Kp is equal to partial pressure of CO2. Don't forget, Kp is equal to partial pressure of CO2. Next, this equilibrium reaction, this reaction depends upon only the concentration of the carbon dioxide and not the calcium carbonate or calcium oxide. This above equation, that is a calcium carbonate solid state, calcium oxide solid state, and carbon dioxide gaseous state. This reaction depends only the concentration of carbon dioxide. Depends upon only the concentration of carbon dioxide, but not the calcium carbonate or not calcium oxide. The active mass, that is active mass means we know that when there is a concentration, the active mass of the pure liquid does not change at a given temperature. The active mass of a pure liquid does not change at a given temperature. That means the concentration terms of the pure liquid can also be excluded from the expansion of the equilibrium constant. Just we can discuss another one example. What is an example means? Carbon dioxide gas reacts with water. It is a liquid state. Okay, carbon dioxide, one of the carbon dioxide gas, we know what is the formula for carbon dioxide? CO2. CO2 gas. This one reacts with water, H2O. This is a liquid state, both forward and backward reaction. Here, one of the hydrogen ion is produced from water. So H plus ions, this is aqueous state, AQ, aqueous state. And also bicarbonate ion, hydrogen combines with the CO2 and along with the oxygen we get bicarbonate ion, that is HCO3 minus. This is also aqueous state. One of the reaction, carbon dioxide plus water is a liquid state, gives H plus ions and bicarbonate ions. We know water is a pure liquid. Water is one of the pure liquid. Here Kc can be written as, for the above reaction, Kc is equal to, don't forget to write, Kc is equal to product divided by reactant. Product divided by reactant. Which one is the product here? H plus aqueous and also bicarbonate, HCO3 minus ion aqueous. This is the product divided by reactant. Am I right? Reactant. Now we can be taken as Kc is equal to H plus ion, H plus concentration of H plus ion, concentration of H3O minus ion, HCO3 minus ion, concentration of HCO3 minus ion divided by concentration of CO2. Concentration of CO2. And one more is, we know that one, that's a water. Already I tell you that water here, the concentration of pure water can also be excluded from the expression of the equilibrium constant. It is excluded. Concentration of water is excluded. We can be omitted the term. Okay, we should not write the liquid also. Okay, there is a water is a liquid. Am I right? So what is about that expression? Kc is equal to H plus ions and HCO3 minus ion divided by CO2. This is the expression for the above equation. Next we can be discuss some other example. What are the examples? How will you write the Kp and Kc? Some other example, that is a sulfur dioxide with oxygen, we get sulfur trioxide. And carbon monoxide is converted into carbon dioxide and carbon. Silver oxide with ammonia, we get silver nitrate and water. These are some example also we can discuss now. One of the very important 3-mark question. Just the first one is, write the Kp and Kc for some reaction. First I am writing the reaction. Number 1. SO2 gas plus O2 gas gives both forward and backward reaction. We get SO3 3 gas, SO3 gas. So how to balance the equation? Product side 3 oxygen, reactant side 4 oxygen. So we have to multiply it by 2 in the product side. So 2 SO3 gas. So come to the reactant side. We have to change it to SO2. Now the equation is balanced. Second on reaction. Carbon monoxide formula CO gas. Both forward and backward reaction we get. Carbon dioxide CO2 gas plus carbon is in solid state. How can you balance the equation? In this equation, the product side is 2 carbon is there, so make it. The reactant side is also 2. Now the equation is balanced. Kp and Kc for the following reaction. How will you write? Kp and Kc for the first equation. I am taking the first equation. Always product divided by reactant. Don't forget that the product divided by reactant. Okay, first you have to take the product. Which one is the product for the first equation? Sulfur trioxide. Kc is equal to sulfur trioxide SO3. Concentration of sulfur trioxide. And also they have the number of moles. Stoichiometric coefficient number of moles is 2 here. So make it to the 2 to the power. Am I right? So sulfur trioxide power 2 divided by. Next come to the reactant. Which are the reactant here? SO2 and O2. So we can written as SO2. Here also the stoichiometric coefficient is 2. Number of moles is 2. So SO2 the power 2 and oxygen is O2. Active mass of O2. Otherwise the concentration of O2. Next, how will you write the Kp for the above reaction? How will you write Kp for the above reaction? Kp is equal to, as per the equation, the first equation, Kp is equal to partial pressure power, because the number of moles is 2 there, so you have to give the number 2. SO3 divided by partial pressure P2 SO2 into partial pressure of O2. This is the first equation, Kp and Kc. Next, how will you write about the next two equation? What's the next two equation? First one is about that carbon monoxide CO. This is in gaseous state, undergoes both forward and backward reaction. We get carbon dioxide CO2 gas plus carbon in solid state. So my dear children, here the reactant and the product are in different phase. Different phases, there is a heterogeneous equilibrium. Carbon monoxide is a gaseous state. Carbon dioxide is also gaseous state. But carbon is in solid state. Before that, you have to balance the equation. Product side 2 oxygen, so the reactant side also make it 2 oxygen. Now the equation is balanced. You have to write the Kc for the above reaction. Kc. How will you write Kc? Kc is equal to, first you have to write the product. Which are the product there? CO2 gas and carbon solid state. CO2 gas. CO2, active mass of CO2 divided by we can't write the carbon. Try to understand the concept. We can't write the carbon. What is the reason means? The concentration of a pure solid is a constant. The concentration of pure solid is a constant. Don't forget that. So I am removing the term. Divided by CO, carbon monoxide, active mass of carbon monoxide, that they have the number of moles is 2. That 2 is make it on the power. That is CO2. Am I right? CO the power 2. Here don't forget, here one term is removed. Am I right? Which term is removed? Carbon in solid state. Already I told you that about the carbon in solid state. Don't forget that. Here the concentration of the pure solid, is a constant. Okay. The next one. Third point. That is third equation. Silver oxide. What is the formula for silver oxide? So, before that, we have to one more point to discuss for the Kc. Kc is over. Next, we have to write the Kp also. How will you write Kp for the carbon monoxide? Kp is equal to partial pressure of carbon dioxide divided by partial pressure of carbon monoxide. Okay, partial pressure of carbon dioxide, that is PCO2 divided by P2CO reaction. How will you write? Kc for the above reaction. Kc is equal to, here we have to write silver nitrate. Concentration of silver nitrate. Otherwise, we can be say active mass of silver nitrate is a concentration of AgNO3. AgNO3. Here, AgNO3, they have one number of moles is 2. That 2 have to write on the power. Okay, that is silver nitrate. Next product is water. We know that one, water. Here, what is about the water? The concentration of terms of pure liquid can be also excluded from the expression of the equilibrium constant. It is excluded. So we cannot be taken because water is, we know that one. Pure water can be taken as a constant like that. Am I right? So I am removing that term. Next, divided by silver oxide. Silver oxide is a solid state. So don't forget that the concentration of pure solid is also constant. So that term also we have removing. What's the remaining last term? That is divided by ammonia, NH3. As per our textbook, here having 2 ammonia. Balance the equation, so make it the power also 2. So Kc is equal to AgNO3 concentration. We have to give the power 2 divided by ammonia concentration power 2. Next, how will you write Kp for the above reaction? Kp, and Kp can be written as partial pressure of silver nitrate. That is partial pressure now. We have to write capital P the power 2. Here we have to write AgNO3 divided by partial pressure P2, because ammonia also having power 2, ammonia, NH3. Okay. These are some expression. How will you write Kp, Kc for the above reaction? My dear children, try to learn these questions. First one is equilibrium constant for the heterogeneous equilibrium. Don't forget that they have the one equation, calcium carbonate is a solid state. This undergoes decomposition, that we get is calcium oxide and carbon dioxide gas. Calcium oxide is a solid state. Carbon dioxide is a gaseous state. Okay. Next we have to write the Kc for the above reaction. So Kc is equal to calcium oxide, but because it is a product side, calcium oxide, this is solid state, and carbon dioxide gaseous state divided by calcium carbonate. Now here calcium oxide and calcium carbonate is a solid state, so we have to remove that one. So we get K is equal to active mass of carbon dioxide. Same like that, Kp is equal to partial pressure of carbon dioxide. Okay. Next, try to take this equation thoroughly, learn systematically. Okay. If you have any doubt, please ask me. Thank you all of you. Thank you. Have a nice day.